Hello, and welcome to the Virtual Appliance Simulation presentation for Whirlpool Incorporated. Whirlpool, a company located in Benton Harbor, Michigan, manufactures appliances including washers, dryers, refrigerators, and dishwashers. We have developed a software-based virtual appliance simulator for Whirlpool that can simulate up to thousands of appliances simultaneously. Why does Whirlpool need a virtual appliance simulator? Household appliances are now often connected to the network. There is a need to develop software for these appliances. However, testing new software on an actual appliance is expensive, especially when an appliance would have to be sent out to the person doing the testing. The hardware you are looking at is the bare minimum required to emulate a Whirlpool appliance. Our virtual appliance simulator has the same functionality with the click of a button. Up until now, Whirlpool has had to ship out an entire actual appliance to wherever they need the testing or development to be done. As you can imagine, this becomes quite expensive for Whirlpool. Also, tests using many appliances would be impossible without having a large number of appliances to do the testing on. Thus, the software-based virtual appliance simulator provides a solution that saves time, effort, and money for developers and testers at Whirlpool. This diagram represents our virtual appliance simulator software solution. As you can see, a virtual appliance looks just like a regular appliance to all of the Whirlpool backend software. The user interacts with a web-based front end to upload files and run the virtual appliance. Within the virtual appliance, there are several different modules. First, the configurator, which takes the configuration files for a machine and does any necessary configuration. Second, the simulation engine, which takes the API file that determines how the appliance will create packets to send to the rest of the world. And third, the scheduler, which takes a script file and creates packets from it and then sends these packets to the appropriate places. Here is an example of our virtual appliance simulator software solution simulating a single dryer. As shown here, we select the default dryer and then go to the next page. On the next page, we upload a script file to run. Additionally, we upload SAIDs, which are unique identifiers or serial numbers for an appliance. Then, we start the appliance. As you can see, information about the appliance running is shown. Packets of information are also sent to the Orient backend, a system Whirlpool uses to provide services to appliances. When the virtual appliance simulator is running, to the network it appears to be a normal appliance. It can send and receive network information from the Whirlpool cloud, and by doing so it emulates the interactions that the cloud would expect from a physical appliance. The Whirlpool Cloud operates on a platform developed by a third-party company called Orient. In order to demonstrate the communication between the virtual appliance simulator and the Whirlpool Cloud, we will be using a tool called the Orient Utility Application that has been provided to us. The Orient Utility Application is a tool intended for developers. It will display the known information about the connected machine in real time. To start out, we register a machine using its SAID or serial number. We may now look at the state of the machine. Currently, the Orient Utility app has no data on our virtual appliance. It is registered as a default appliance and is shown as offline. If we start up the virtual appliance, we can then initiate the communication with the Whirlpool cloud. Now that the appliance is running, we let the Orient Utility application know that it is okay to start communication. As shown here, the virtual appliance has received a data packet. It then returns this larger packet containing information such as appliance type and MAC address. Once the Whirlpool cloud receives this packet, it parses it and updates the information about the machine. Note that the virtual appliance is recognized to be a Whirlpool dryer. The serial number, MAC address, and other important information is also displayed. The appliance is also shown to be online. The script file that the virtual appliance runs is generated using a tool we call the script file generator. To use the script file generator, you must first have an API file for the appliance. The API file tells our simulator how to properly emulate an appliance. Once we have chosen an API, the script file generator can be loaded. Here, we will fill out how we want the appliance to behave in the simulation. We do this by selecting the proper network packets or messages that we will be sending. The first piece of information the script file generator needs is which API you want a packet from. Here, we choose the Dryer Appliance Interface API. Next, we choose an opcode that determines what the packet is supposed to do. Here we are going to create a script which checks to see the status of our appliance, a dryer. So, after picking the right opcode, we now need to set the correct options for each of the elements that have been dynamically populated based on our prior selections. This packet is going to check if the clothes in the dryer are wet. It will run for 4,000 milliseconds, the time for which we enter in the box here. Now, we create the packet by pushing the button. The script file generator provides two displays for the user. First, there is an overview that shows the API and opcode for each packet. Second, there is a longer, more detailed XML script that can also be viewed. Let's add a second packet that will check if the clothes are dry. Notice that this is the same API, but that a different element has been chosen. This packet will run for 5,000 milliseconds. Again, we create the packet. It looks good, so we can save the script now. Now we can load the script into the virtual appliance. Multiple appliances can be run at once. Here is a demonstration of running 3 different appliances with 3 different scripts at once. The only limit on the number of appliances you can run is the number of SAIDs you have. Our virtual appliance simulator is developed mostly in Java and optimized to run on Linux. The front end is in PHP with JavaScript. The virtual appliance simulator will be of great use to Whirlpool in developing software for appliances. We'd like to sincerely thank our Whirlpool clients for providing us with the opportunity to develop this project. We'd like to acknowledge two very important people who helped make this capstone project possible. That would be our professor, Dr. Dykeson, and our TA, Malcolm Doring.